All right, my stews. Number 6. Now, number 6 is very similar to number 5. See, check it out. You see number 5 right here? This has 2 perfect cubes, and this one has 2 perfect cubes. And you might be going like, what? I don't see that those are perfect cubes. How am I supposed to know that 216 or 512 are perfect cubes? The reason why you would know is because you would check. Because you see, that's a perfect cube. And so my guess is maybe that's a perfect cube. Same with this one. 27 is a perfect cube. You should know that 27 is a perfect cube. If you don't, now you know. How do I know perfect cubes? This is what you do. You think about whatever you can cube to get a number. So think about 1. If I cube 1, what do I get? 1.
What?
If I cube 2, what do I get? 8. If I cube 3, what do I get? 2 or 3 times 3 times 3, yeah, 27. If I cube 4, what do I get? 64. If I cube 5, what do I get? 125. And usually at this point we're good, but this is 512, so I want to keep going to see if we get somewhere. What is 6 cubed? So we had 216. And then what is 7 cubed?
340.
I remember seeing 216 on number 5, didn't you? Oh, what was 7 cubed? 343. Almost there. 8 cubed.
512.
512. There he is. Now, if I pass 512, then I know that this would not be a perfect cube. Okay, so I know these are both perfect cubes. Therefore, I'm going to use a difference of cubes. So let's put our binomial and put our trinomial. And let's find all our numbers. What is the cubed root of that guy? It is 3x. What is the cubed root of that dowgay? We just figured that out. That was 8. So how do we get the rest of our numbers? We go 3x times 3x, which is 9x squared. Then we go 3x times 8, which is 24x. And then we go 8 times 8, which is 64. What are my signs? Keep, change, plus. Keep the sign, change the sign, plus. Keep the sign. That sign right there. That's what we're talking about. So, after that, you guys should think, oh, can I factor more? This guy cannot be factored more. This guy looks like he can be factored more. And let me prove to you guys that he can never be factored more. This is why you think he can be factored more. I mean, why you might think it can be factored more. This is a perfect square right here, and this is a perfect square. We have 9x squared, which is a perfect square, and 64. And normally, sometimes, if you have these two as perfect squares, then this guy will fall in line, and this will be a perfect square trinomial, usually. And if it's a perfect square trinomial, what you can do with that is you can write it as a perfect square. So like if you had 3x plus 8, this is what you might be thinking. Like, oh yeah, this squared would give me that. It won't. Watch, check this out. So I'm going to go 3x plus 8, both of them. And then I start multiplying. What is 3x times 3x? That's 9x squared. And I have 3x times 8, which is 24x. And then I go 8 times 3x. I get 24x again. And there's the problem. You see it? You see it? 8 times 8 is 64. Hey, that's not a problem. No, it's not. But look at this. 24 and 24 is 48. That should be a 24 in the middle. So therefore, it doesn't work. This is not factorable, which is kind of sad for you. Yeah, we have a lot of work to do now. Okay, so let's first take this first guy, who is not a lot of work, and set him equal to 0. You add 8 to both sides. Divide both sides by 3. Dog, that's it. You got the answer for that one. Okay. Now, I'm not finished. That's just for that factor. What about this factor? Oh, snap. Yep, quadratic formula is right. I heard somebody say it. We gotta use the quad form. So we got negative b. You guys have calculators ready? Because these are big numbers. Negative b plus or minus the square root of b squared, 24 squared. Oh, that's icky. Minus 4 times a times c, which is 64. No more, please. Okay, then 2 times 9. All right, so that's going to be 18. And then what is 24 times 24, Stews? I thought you got your calculators ready. Come on. What's 24 times 24? 576. And what is, okay, it looks like this is going to be minus because there's only one negative there. They have 4 times 9, which is 36. What's 36 times 64? Come on, give it to me. 2,304. Okay, can you subtract 576 from that? Okay, so we have 24. Make sure I write it right. Negative 1728. Okay, let's make sure that looks like an 8. Okay, and that's divided by 18. Oh, dang. Now, there's a negative in there, and I could take this negative out by putting an I out here. Okay? So it's a complex number. Can I simplify this down? Okay, now we listed a bunch of perfect cubes. Let's list a bunch of perfect squares. We have 1, and then 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. Can you guys start dividing 1,728 by any of these numbers and see if any of them divide it? 7 times 7 is 49, and then 8 times 8 is 64, and then 9 times 9 is 81. All right, I'm guessing, I mean, we can go on, but one of these has to divide this. And if not one of these, then I'm done. And I'm not going to simplify. Okay, so you guys found out that 64 does it. Does a smaller perfect square divide it also?
4.
4 divides it?
Yeah.
Okay, so I want to show you guys what would happen if you accidentally chose 4 instead of 64. You want to pick the biggest number, but what if you didn't see it? What if you're like, oh, 4? And so you go square root of 4 times the square root. What did you get when you divide it by 4?
432.
Okay, after that, you should notice right here, hey, I can divide it by 4 again. You guys see that? Yeah. So square root of 4, then the square root of 1, 0, 8. Mm-hmm. And then isn't that divisible by 9? Mm-hmm. Yeah, so like we still have more numbers that we can divide it by. We can keep taking perfect squares out. And so this would be square root of 9, then we go square root of, what is that? Is that 12? Yeah. Oh dang, and I could take another 4 out. This is getting like yucky. Okay, so square root of 4, square root of 3. So this is a 2, this is a 3, this is a 2, this is a 2. What is 2 times 2?
4.
Times 3?
12.
Times 2? 24. Oh, snap. So I could have taken out whatever. Wait, is that right?
Yeah. Didn't you? Yeah.
That is 24. So we get negative 24 plus or minus 24 divided by, or square root of 3. And don't forget your I. You can put the I there, you can put it right after the 24. It don't matter. Whenever I put the I out here, I make sure I put a hangy thing on the end of my square root so I know that the I is not inside of it. All right, now can I take out something at the top and factor out something at the bottom so I can cancel out? The biggest number possible. 3 would work. 6 would be even better. So if I took a 6 out, that would be negative 4, and this would be 4, and this would not be an 8 anymore. It would be a 3. There'd be a 6 right there, and peace out 6s. So we have negative 4 plus or minus 4 rad 3i divided by 3. So your final answer in standard form is going to be negative 4 over 3 plus or minus 4 over 4 rad 3 over 3i. Oh, that is a lot of business right there. Backtrack really quick. If you thought of 64 right at the beginning, check this out. Square root of 64 times the square root of 27, right? You said 1,728 divided by 64 is 27, right? Yeah. Okay, that's an 8, right? Uh-huh. Okay, can I split this up even more? 9 and rad 3. And what is the square root of 9?
3.
So what is 8 times 3?
24.
So we still get the same thing. Yeah, but that one was way shorter, huh? Yeah.
Yes.
Except I don't know the multiples of 64, so I don't know how likely I would have done that. I probably would have done this, like honestly.